Welcome to lecture series on power screw, design of power screw. Today we are going to discuss the problem on a two-start square threaded screw. So problem statement is in this way. A vertical two-start square threaded screw of 100 mm diameter and 20 mm pitch supports a vertical load of 18 kN. The nut of the screw is fitted in the hub of a gear wheel having 80 teeth, which meshes with the pinion of 20 teeth. The mechanical efficiency of the pinion and gear wheel drive is 90%. The axial thrust on the screw is taken by a collar bearing whose outside diameter is 250 mm and inside diameter is 100 mm. By assuming uniform pressure condition, find the minimum diameter of the pinion shaft and height of the nut when the coefficient of friction for the vertical screw and nut is 0.15 and that for the collar bearing is 0.20. The permissible shear stress in the shaft material is 56 megapascal and the allowable bearing pressure is 1.4 Newton per mm square. So in the given problem, this is a problem on a two-start square threaded screw. So this problem is on a double start or two-start square threaded screw. So for two-start square threaded screw, n is equal to 1, number of starts equal to 1, number of starts equal to 2. So n is equal to 2 and the mean diameter is 100 mm. So let us mark this mean diameter as dm. Dm is equal to mean diameter of this screw, that is 100 mm. Then pitch of the screw is given 20 mm and this screw supports a vertical load. W is the vertical load and that is 18 kilonewton. So 18 into 10 raised to 3 Newton. 18 into 10 raised to 3 Newton. So W is the vertical load that is supported by the screw. Then this nut of the screw is fitted in the hub of a gear wheel having 80 teeth. So TG is nothing but number of teeth on a gear wheel. So number of teeth is 80. So TG is equal to 80 teeth, which meshes with the pinion of a 20 teeth. So TP is nothing but the number of teeth on a pinion. So TP is equal to 20. The mechanical efficiency of pinion and gear wheel drive is 90%. So mechanical efficiency is eta G or eta mech or eta G is equal to 90%. 90%. So it is 0.90. Then this axial thrust on the screw is taken by the collar bearing whose outer diameter is 250 mm and inside diameter is 100 mm. So capital DO is the outside diameter of this collar. So DO is the outside diameter of the collar, that is 250 mm. 250 mm. So from that we can find out the outer radius of this collar. Outer radius is half of the diameter, so 125 mm. Then inner diameter of this collar, DI is given 100 mm. DO and DI are the outer and inner diameter of the collar. So RO and RI we can calculate the value. RO and RI are the outer radius and inner radius of the collar. So inner radius is half of the diameter, that is DI. So it is 50 mm. So outer and inner radius of this collar bearing, that is given to us. And it is said that assuming uniform pressure condition. So we have to use the uniform pressure condition for this problem. Find out the minimum diameter of the pinion shaft and height of the nut. So minimum diameter of the pinion shaft. So let us say this is DP. DP is the diameter of the pinion shaft. Diameter of the pinion shaft. So we have to calculate this minimum diameter of the pinion shaft required in this case. So this we have to calculate. Then height of the nut. So it is denoted as H. H is nothing but height of the nut. That also we have to calculate. Height of the nut we have to calculate. So H we have to calculate. And the coefficient of friction. When the coefficient of friction for the screw and nut is 0.15. So mu is the coefficient of friction between the screw and nut. So it is 0.15. And mu C, that is coefficient of friction for the collar bearing, that is mu C, denoted as mu C. So it is 0.20. The permissible shear stress. So tau permissible. This permissible shear stress is 56 megapascal. 56 megapascal. And allowable bearing pressure, that is PB. PB is the bearing pressure. Allowable bearing pressure is 1.4 Newton. 1.4 Newton per mm square. So this is the given problem statement. given problem statement. So in this case, we have to find out the diameter, minimum diameter of the pinion shaft and the height of the nut. So for calculation of the minimum diameter of the pinion shaft, we need to calculate first the total torque required for this case. So our first step is calculation of the total torque for this screw. So while calculation of the total torque, we have to calculate the torque required to overcome the screw thread friction. So calculation of the total torque. So total torque T. So first we have to calculate the torque required to overcome the screw thread friction. So we have to calculate the torque required to overcome the screw thread friction. Torque required to overcome the screw thread friction. Overcome screw thread friction. In our previous lecture, we have solved a problem on this two-start square threaded screw. So very first torque that we have to calculate is TS. So formula for TS is load W into tan of lambda plus phi. This is W into tan of lambda plus phi is the effort into mean radius, that is the mean diameter divided by 2. So effort into mean radius is nothing but torque required to overcome the screw thread friction. So in this case, W is given. We have to calculate this tan of lambda plus phi, where lambda is the helix angle or lead angle, phi is the friction angle, dm is the mean diameter that is given in the problem, that is 100 mm, and mean diameter divided by 2, that is mean radius. So here we have to calculate first this lead angle or helix angle. So we'll mark this as the equation. This is the equation 1. Now we'll calculate these values. So very first value, that is a helix angle or lead angle in this case. So helix angle or lead angle is equal to, formula is tan of lambda is equal to lead divided by pi into d, pi into dm. So we have to calculate the lead, as it is a double start screw thread. So lead is equal to number of start into pitch. So lead is equal to number of starts are 2 and pitch for this problem is 20 mm. Pitch is 20 mm. So lead value is equal to 40 mm. So we can now put the value and find out the value of tan lambda. So tan lambda is equal to lead is 40 mm divided by pi into dm. Dm is 100 mm. So we can now calculate tan of lambda, this value, tan of lambda. So this value comes out 0.1273. So tan of lambda, this value is 0.1273. So we will mark this as equation A. So tan of lambda is this value. Now we have to calculate the friction angle. So friction angle is nothing but phi. Friction angle phi. So friction angle, we know the coefficient of friction mu is equal to tan of phi. Coefficient of friction mu is the coefficient of friction between screw and nut. So mu is equal to tan of phi. Mu value is given to us. So tan of phi is equal to mu value is 0.15. It is given in the problem. We can see mu value is 0.15. So tan of phi is equal to 0.15. So now we can calculate this tan of lambda plus phi, this value. So there is a formula for tan of lambda plus phi. Tan of lambda plus phi is equal to tan lambda plus tan phi. Tan lambda plus tan phi upon 1 minus tan lambda into tan phi. This is the formula for tan lambda plus phi. So putting the values, tan lambda is 0.1273 plus tan phi value is 0.15 divided by 1 minus 0.1273 multiplied by 0.15. So from this we obtain a tan of lambda plus phi value. So this value after adding and dividing this we get the answer, that is 0.2827. So tan of lambda plus 5, this is 0.2827. So we have to put this tan of lambda plus 5 value 0.2827 in the equation 1, that is the equation of torque required to overcome the screw thread friction. Then we are able to calculate the torque required to overcome the screw thread friction, that is TS value. So we have to now calculate the torque required to overcome the screw thread friction. So putting the values, so TS is equal to, load is 18 kilonewton, so 18,000 Newton, so 18,000 Newton into tan of 5 plus lambda, this value we have just now calculated, that is 0.2827. So this value is 0.2827, 0.2827 multiplied by DME is 100 divided by 2, so it is 50. So from this we are able to calculate the torque required to overcome the screw thread friction, and it comes out 254.43 into 10 raised to 3. And the unit of the torque is Newton into mm. So we'll mark this is a TS value, so we'll mark this as equation number 2. Now after calculation of TS, we have to calculate TC, that is torque required to overcome the collar friction. So next step is B step, we can say, torque required to overcome the collar friction. That is denoted as a TC, torque required to overcome collar friction. And there is a uniform pressure theory to be used for calculation of this torque. So considering uniform pressure theory for calculation of this collar friction torque, so assume uniform pressure theory. It is mentioned in the problem that you used uniform pressure theory for calculation of the torque required to overcome the collar friction. So uniform pressure theory, using uniform pressure theory for calculation of this torque. So as per uniform pressure theory, the mean radius of the collar is calculated by the formula RM. Mean radius of the collar is given by, that is RM. So formula for RM, mean radius of the collar, for assuming uniform pressure theory, so that formula is 2/3 of RO cube, outer radius cube, minus RI cube upon RO square minus RI square. RO and RI are the outer and inner radius of this collar bearing. So putting the values, we can calculate the mean radius. So RM is equal to 2/3 into RO and RI are given in the problem. RO is 125 mm. It is outer diameter of the collar bearing is 250 mm. So RO is 125, half of that, and inner diameter is 100 mm. So RI is 50. So putting these values here, so 125 cube minus 50 cube divided by 125 square minus 50 square. So we are now able to calculate the mean radius of the collar, and after calculation, this mean radius is 2/3 into this value is 139.29. So mean radius of this collar is 92.86 mm. Mean radius of this collar is 92.86 mm. So we'll mark this as equation D. Now we have to calculate the collar friction torque required to overcome the collar friction. So it is also called as a collar friction torque. So collar friction torque TC is given by this formula. So TC is equal to mu C into W into RM. So putting the values, TC is equal to mu C, that is the coefficient of the friction in the collar bearing, is 0.20. So putting this value 0.20 multiplied by load is 18,000 Newton multiplied by mean radius is 92.86. So we get this collar friction torque. So collar friction torque for this problem is 334.30 multiplied by 10 raised to 3. This is in Newton into mm, and we'll mark this as equation 3. So we have calculated torque required to overcome the screw thread friction and the collar friction. So summation of these two is equal to total torque. So total torque in this case, so we'll mark as a C step, that is total torque T is equal to total torque T is equal to Ts plus Tc. Total torque is summation of torque required to overcome the screw thread friction plus collar friction. Torque required to overcome the collar friction. So we can now calculate the total torque in this case. Ts we have calculated initially 254.43 into 10 raised to 3 plus this collar friction torque we have calculated, it is 334.30 into 10 raised to 3. So we will get now the total torque on the gear wheel. This total torque is acting on a gear wheel. So total torque is 588.73 into 10 to the power 3 Newton mm. So this we get the total torque acting on the gear wheel. So we'll mark this as equation 4. Now next is to calculate the minimum diameter of the shaft, pinion shaft. Next step is for calculating the minimum diameter of the shaft. Next step is calculation of the minimum diameter of the pinion shaft. That is dp. This we have to find out in the problem. So for that purpose we have to use the formula of mechanical efficiency. So efficiency is equal to total torque divided by torque on the gear wheel. So mechanical efficiency is given as total torque divided by torque on a gear wheel. So that is equal to total torque T divided by Tg. Tg is nothing but the torque on a gear wheel. So torque on a pinion is expressed as, so we know torque on a pinion is calculated as, we know gear ratio. Gear ratio is nothing but it is a ratio of number of teeth on a gear wheel to the number of teeth on a pinion. So Tj upon Tp is the gear ratio. So here number of teeth on a gear is 80 divided by number of teeth on pinion is 20. So gear ratio is 4. So gear ratio is nothing but Tg upon Tp, or torque on gear wheel upon torque on pinion. So this ratio is 4. Gear ratio is 4. So we can express Tg in terms of Tp as, this equation say Tg is nothing but torque on a gear wheel is equal to gear ratio G times Tp. So we have to put this Tg is the torque on a gear wheel is equal to G, that is gear ratio times torque on a pinion. So we can calculate now the torque on a pinion. So torque on a pinion is given by Tp is equal to we have the formula of mechanical efficiency, eta G is equal to T upon Tg. This is the mechanical efficiency formula. So Tg is expressed as G into Tp. So mechanical efficiency of the gear drive is equal to total torque divided by Tg. Tg is nothing but G into Tp, gear ratio into torque on a pinion. Gear ratio times torque on a pinion. So from this we can calculate the Tp, that is torque on pinion, is equal to total torque divided by mechanical efficiency of the gear drive, eta G into gear ratio, that is G. So from this formula we can calculate the torque on pinion. So torque on pinion is expressed as, Tp is equal to T upon G into eta G. T total torque T divided by gear ratio into mechanical efficiency. So we can put now the values. Total torque is 588.73 into 10 raised to 3 divided by gear ratio is 4. So gear ratio is 4 and mechanical efficiency is 0.90. 90% mechanical efficiency. So from this we can calculate the torque acting on a pinion shaft. So this comes out 163.54 into 10 raised to 3. This is the torque acting on a torque acting on a pinion, TP. TP is nothing but torque acting on a pinion shaft. इतना है. Now using torsion equation, torsion of shaft concept, using torsion equation we can find out the diameter of the pinion shaft. So using torsion equation we can find the diameter, shaft diameter. So torque transmitted by pinion is given by this formula, pi by 16 into tau into dp cube. Pi by 16 into tau into dp cube, where tau is the permissible shear stress, TP is the torque acting on a pinion shaft. So ये फॉर्मूला कैसा है, T by J is equal to tau by R. This is the equation. So T is nothing but TP here, and J is the polar moment of inertia of the circular cross section of the shaft. J कितना होता है, J is pi by 32 into dp raised to 4. इतना होता है J, polar moment of inertia of the shaft, pinion shaft. R is nothing but dp by 2. Diameter of pinion divided by 2. ये वैल्यू अगर पुट अप करेंगे तो इक्वेशन क्या बन जाएगा, TP अपॉन J pi by 32 into d raised to 4 है, dp raised to 4 है, that is equal to shear stress tau divided by radius r is dp by 2. तो ये वर्कआउट करने के बाद pi by 32 into dp raised to 4 into tau divided by dp by 2. So this equation becomes TP is equal to pi by 16 into tau into dp cube. ये इक्वेशन इस तरह से आ रहा है. वर्कआउट करने के बाद इक्वेशन टीपी का इस तरह से है. टीपी इज व्हाट, टॉर्क एक्टिंग ऑन अ पिनियन शाफ्ट. तो इसका इतना वैल्यू होता है, टीपी इज इक्वल टू पाई बाय 16 टाउ परमिसिबल इनटू डीपी क्यूब. तो पुटिंग द वैल्यूज, सो टीपी का वैल्यू हमने कैलकुलेट किया था 163.54 into 10⁻³ न्यूटन into mm. सो टेकिंग दिस वैल्यू 163.54 into 10⁻³, दिस इज द टॉर्क एक्टिंग ऑन अ पिनियन शाफ्ट, दैट इज इक्वल टू पाई बाय 16 into टाउ परमिसिबल इज गिवन इन द प्रॉब्लम इटसेल्फ. ये प्रॉब्लम में ही दिया था हमें, टाउ परमिसिबल का वैल्यू दिया है प्रॉब्लम में. टाउ परमिसिबल इज 56 मेगापास्कल. तो ये वैल्यू यहाँ पे लेना है हमें. टाउ परमिसिबल इज 56 मेगापास्कल मल्टीप्लाइड बाय डीपी क्यूब. सो फ्रॉम दिस we are able to calculate the value of dp, diameter of pinion, by taking 1/3 root of ये डीपी क्यूब का पहले वैल्यू मिलेगा और उसका 1/3 रूट लेने के बाद हमारा आंसर आएगा डीपी का 23.82 mm. सो डायमीटर ऑफ पिनियन इज अप्रोक्सीमेटली is 24 mm. दिस इज आवर फर्स्ट रिक्वायर्ड आंसर फॉर दिस प्रॉब्लम. ये आंसर फाइंड आउट करना था हमें. मिनिमम डायमीटर ऑफ पिनियन शुड बी 24 mm, अप्रोक्सीमेटली 24 mm. एग्जैक्ट वैल्यू इज 23.82 mm. ये पहला आंसर है इस प्रॉब्लम का. अभी दूसरा आंसर है हाइट ऑफ द नट. हमें दूसरा आंसर फाइंड आउट करना है. सो फॉर फाइंडिंग आउट द हाइट ऑफ द नट, फर्स्ट वी हैव टू कैलकुलेट द आउटर डायमीटर ऑफ द स्क्रू, DO. सो DO इज कैलकुलेटेड एज मीन डायमीटर प्लस पिच बाय 2. मीन डायमीटर वाज गिवन 100 mm प्लस पिच 20 mm था, 20 by 2. तो DO इज इक्वल टू 100 प्लस 10, दैट इज 110 mm. DO आया, DO is the outer diameter of the screw. Yeah, 110 mm. Now we have to find out the core diameter or DI, inside diameter of the screw. So core diameter is equal to mean diameter minus pitch by 2. So mean diameter is 100 minus pitch is 20 divided by 2. So 100 minus 10 is 90 mm is the core diameter. 90 mm is the core diameter for this problem. तुमने आउटर डायमीटर और कोर डायमीटर हमने फाइंड आउट कर दिया. नाउ वी हैव टू कैलकुलेट द नंबर ऑफ थ्रेड्स विच आर इन एक्चुअली एंगेज्ड. नंबर ऑफ थ्रेड्स ऑफ द स्क्रू एंड नट विच आर एक्चुअली एंगेज्ड. सो नंबर ऑफ थ्रेड्स विच आर एक्चुअली एंगेज्ड. स्क्रू और नट के कितने थ्रेड्स यहाँ एंगेज हुए हैं एक दूसरे में, वो हमें कैलकुलेट करना होगा. तो इसके लिए हमें बेरिंग प्रेशर का फॉर्मूला यूज करना होगा. So bearing pressure is given as the load W divided by area. Area is pi by 4 into DO square, outer diameter square, minus DC square, that is core diameter square, multiplied by number of threads which are actually engaged. ये फॉर्मूला है बेरिंग प्रेशर का. तो बेरिंग प्रेशर प्रॉब्लम में दिया है हमें, यहाँ पे गिवन है ये वैल्यू. बेरिंग प्रेशर इन द प्रॉब्लम इज 1.4 Newton per mm square. Bearing pressure is 1.4 Newton per mm square. So taking this value, so bearing pressure is 1.4 Newton per mm square. The load is 18,000 Newton divided by pi by 4 into DO is 110 square minus DC is 90 square and multiplied by NT. NT is nothing but number of threads which are actually engaged. Number of threads of the screw and nut which are actually engaged. So from this we can calculate the number of threads which are actually engaged. So that answer comes out 4.09. So approximately it is 5 threads. So 5 threads of the screw and nut are actually engaged. Therefore, the height of the nut H is calculated as number of threads which are actually engaged multiplied by pitch. So height of the nut is equal to NT, that is 5. Number of threads actually engaged between the screw and nut is 5 multiplied by pitch is 20. So in this case, height of the nut is 100 mm. So this is the second answer for this problem. H is equal to 100 mm. This answer is nothing but height of the nut. Height of the nut should be 100 mm. 100 mm for this problem. तो ये हमारा दूसरा आंसर है. ये दो आंसर हमें फाइंड आउट करने थे इस प्रॉब्लम में, तो हमने ये दो आंसर फाइंड आउट कर लिए. तो इस तरह से ये प्रॉब्लम सॉल्व करना है हमें. प्रॉब्लम का सोल्यूशन थोड़ा लंबा है, लेकिन स्टेप बाय स्टेप उसको कैलकुलेट करना है. पहले टोटल टॉर्क कैलकुलेट करना है. टोटल टॉर्क से मैकेनिकल एफिशिएंसी का फॉर्मूला यूज करके T अपॉन मैकेनिकल एफिशिएंसी इक्वल टू टोटल टॉर्क अपॉन टॉर्क एक्टिंग ऑन गियर व्हील T अपॉन TG. फिर गियर रेशो का फॉर्मूला है TG अपॉन TP. वहां से हमें TP का इक्वेशन फाइंड आउट करना है, वो टॉर्क कैलकुलेट करना है, टॉर्क एक्टिंग ऑन पिनियन शाफ्ट. Then by using the formula of torsion of the shaft, torque transmitted by the pinion shaft, TP is equal to pi by 16 into tau permissible into dp cube. तो यहाँ dp पहले निकाला, फिर आउटर डायमीटर कोर डायमीटर ये कैलकुलेट किए और बेरिंग प्रेशर का फॉर्मूला यूज किया. बेरिंग प्रेशर फॉर्मूला इज एक्सियल लोड W डिवाइडेड बाय एरिया ऑफ द स्क्रू एंड नट विच आर एक्चुअली एंगेज्ड इज pi by 4 into DO square minus DC square into N. N is the number of threads which are actually engaged. तो n कैलकुलेट किया, height of the nut is equal to n into p. So nt is nothing but number of threads actually engaged multiplied by pitch is 20. So we get the height of the nut. So in this way we have to solve the problem on a two-start square threaded power screw for this application. So thank you very much. See you in the next lecture on another important problem on this. Thank you.